When I say Marco scored 14 of the team's 35 points, I'm comparing two numbers. The ratio of the points Marco scored to the points the team scored is 14 to 35. You can write the ratio as 14 to 35, or as a fraction, or as a decimal, or as a division problem. These expressions are all equivalent. There are two important vocabulary words in this section. The ratio is a comparison between two quantities, often written in fraction form. A proportion is an equation stating that two ratios are equal. Here is one true proportion and one false proportion. You can check that a proportion is true by finding the decimal equivalent of each side. 9 divided by 15 and 3 divided by 5 both equal 0.6. So the first proportion is true. 3 divided by 15 equals 0.2, but 5 divided by 9 equals 5/10 repeating. So 3/15 does not equal 5/9. An O-gauge model train is built on a 1 to 48 scale. This means that 1 inch on the model corresponds to 48 inches, or 4 feet, on a real train. A Yellowstone type locomotive, one of the largest ever made, measured 128 feet in length. How long is an O-gauge model of this locomotive? We need to pay close attention to the units in this example. Our scale uses inches, but the actual length is measured in feet. We need to change 48 inches into feet. 48 inches is equal to 4 feet, so we can write the ratio as 1 inch to 4 feet. To figure out the length of the model, we can set up a proportion. Because 4 times 32 is 128, you multiply the numerator and the denominator of the fraction on the left by 32 to get the same denominator as in the fraction on the right. So the equivalent fraction is 32 over 128. The model is 32 inches long. In algebra, a variable stands for an unknown number or numbers. We can turn the train equation into an algebraic equation by using an x instead of a question mark. We call x a variable so we can replace x with any number, but in this case, only one number will make it true. When you multiply both sides of an equation by the same number, the two sides remain equal to each other. You can use this idea to solve a proportion with a variable in one of the numerators. For example, you can solve m to 19 equals 56 to 133 by multiplying both sides by 19. "19 divided by 19 equals 1, so on the left all we're left with is m. 56 times 19 divided by 133 equals 8, so m must equal 8. We can check our answer by substituting 8 back into the original proportion and verifying that we have a true proportion, which we do. Here's one for you to try. You're welcome to use the pause button if you need more time to look at the solution. When you have a proportion where the variable is in the denominator, just invert the ratios and use the same method. For example, 12 to p equals 176 to 132. Well, that's the same thing as p to 12 equals 132 to 176. We can multiply both sides of the equation by 12. 12 divided by 12 equals 1, so we're left with p on the left side. On the right side, 132 times 12 divided by 176 equals 9. So p equals 9. And here's another one for you to try. And a solution. Feel free to hit the pause button if you need more time. Raj answered 75% of the questions on the algebra midterm correctly. If he got 27 correct answers, how many questions were on the test? When a problem involves a ratio or percent, you can sometimes solve it by setting up and solving a proportion. For example, we'll let Q represent the number of questions on the test. Using the fact that 75% is 75 out of 100, we can write a proportion. We need to think carefully about where the 27 goes. 27 is not the total number of questions on the test, it's only the number of correct answers you got. So we're not going to put it in the denominator with the 100, we'll put it in the numerator with the 75. So we have 75 to 100 equals 27 to Q. Since Q is in the denominator, we will invert the proportion, multiply both sides by 27, and simplify. 27 times 100 divided by 75 equals 36. So there must have been 36 questions on the test.